That's because essentially it's set up to look like the surface of Mars, and it's inside of a building, right? Now, what we'd like to do is test the actual real rovers going to Mars. The only problem is if you test the actual real rovers that are going to Mars in a condition like you see here, where it's kind of dirty, you might contaminate your spacecraft, right? And one of the main things we're looking for is possible signs of life where we're going, so it's very important that we keep our spacecraft clean. So the real rovers that go to Mars are never actually exposed to conditions like this. And what we do is we build a whole spare rover that we use just for testing. And that's what we're looking at in here right now, are the DTM versions of the rovers that went up to Mars. And we'll talk about the small one first. If you look in the bottom to the right, you'll notice there's a rover sitting here just to the right. You guys see that in the bottom right? Yeah. That smaller rover, that's the DTM, or design test model, for the rovers that went up 8 years ago, Spirit and Opportunity. It was built around the same time, works the same way, has the same parts, same size, does everything the real one does. The idea being that if we test this and it works, then it works on the real thing, most likely. If we test this one and it doesn't work, then it probably won't work on the real thing either, right? So that's what we use it for. Now, that one that you're looking at is exactly like the real thing, except you'll notice there's no solar panels on it, right? Because we tested it inside a building, so you figure why spend that money on there. So it has no solar panels. And the other difference is there's no actual electronics on the inside. If you opened it up, there's no brains or guts in it. And the reason for that is the guts and brains of it are actually on computer racks underneath us. And the reason they did that was when they were doing testing, sometimes they had to replace parts. And if you put all the stuff on the inside, if you have to replace it, guess what? You have to take the whole thing apart and then put it back together again. And every single time you do that, it's more likely you're going to break something or damage something. Not to mention, it's more time consuming if you do that. So what they did was they left all the internal stuff, the guts, the brains, the computer systems for the rovers, on computer racks underneath us. That way, if they needed to replace something, they just pull the rack out, change the parts, stick it back in, you're good to go. It takes you 10 minutes, right? So that's why they've done that. So this rover you're looking at is just like it, except it doesn't have the brains or guts on the inside, and there's no solar panels on it, right? Now, the other rover you're looking at, the big one that's sitting right here in front of us, this is the DTM for the new rover, the Mars Science Laboratory, the one we've been talking about, the one that launched 4 months ago. It's the same size, the real thing, looks just like it, and it's basically has pretty much all the same parts. There's a few parts there that are not real. For example, if you remember, I pointed out they have that nuclear battery at the rear end, right? And if you look at this model right now, the front of it is facing towards us. You can see the robotic arm in the front. And the rear end of it is kind of facing towards the wall, right? And if you look at the rear end, you'll notice it has two brass plates kind of sticking up from the rear end. Do you guys see that? But if you look in the middle, it doesn't have that barrel with fins on it, right? And that's because there's no nuclear battery on this. Being radioactive, we're not allowed to test it here, right? So we don't have a battery. All the electricity comes from the long umbilical cord you see plugged into the rear end. So you might notice there's that big cord plugged into the rear end, so it's actually plugged into the wall, right? So this is basically just like the real thing. It works just like the real one, same size as the real one. The idea being that if we test this one and it works, then it should work on the real thing. If we test this one and it doesn't work, then it probably won't work on the real thing either, right? So that's the whole idea with this one. Now, you're probably wondering, well, you already built it. We just said that we launched it 4 months ago, right? And it's already all done. It's in a capsule. It's flying to Mars. Well, what kind of testing could you be doing in here, you're probably wondering, right? Well, the thing is, even though it's on its way to Mars, you have to remember this is a big robot, right? And robots need programming to tell it what to do. And we have programming for this. The only thing is they weren't quite finished with it yet. And the thing is, if we delayed the launch for the programming, we would have to wait until the planet goes back around again. And Mars and Earth are lined up in a position for us to go to it once every 2 years. So if you miss your window, you actually have to wait another 2 years, right? So we didn't want to have to wait another 2 years.